Hello, welcome back to the world of limits. This is taking us back to September and October when we first did limits. Also, when we just recently did limits, we can now apply L'Hopital to all of our other problems before. So we're not going to be looking at, oh, can you do it this way or that? Just can you find the limit? Okay, so the first one is the limit as x approaches pi halves of cosine of x. Okay, so our first technique for finding limits was just direct substitution. So I just go ahead and plug pi halves in here for x. And if I know cosine of pi halves, then I know the limit as x approaches pi halves of cosine of pi halves. And so I know that's 0 because my exact value, cosine's x at 90 degrees or pi halves radians is 0. Okay, second one, again, if I try direct substitution, I end up with 3 times 2, which is 6 minus 6, over 2 minus 2, which ends up being 0 over 0. So we can apply L'Hopital's rule, because it's 0 over 0, and that tells me I can take the limit as x approaches 2 of the derivative, which is 3 of the top, over the derivative of the bottom, which is 1. Okay, and this is just a constant, and the derivative of any constant is just that constant. And again, think about that graphically. What does that mean? Well, this is my function, right? Y equals 3, which would just be a horizontal line at 3. Okay, and if you remember that limit, as I approach 2, I'm seeing what does this graph approach from the right and from the left. And you can see that no matter what value you're approaching, whether it's 2, negative 2, 0, you can see that that function will always have a value of 3. Okay, but maybe you don't want to use his rule, so we go back to the technique that we learned when we were first doing limits, and we need to simplify this expression first. 3x minus 6 over x minus 2, and one of our favorite techniques was factoring. So I factor out what they have in common, which is a 3. On the bottom, you're just left with x minus 2, and you can see those guys cancel off. And so now we are taking the limit as x approaches 2 of 3, which again is just 3. Okay, so you can, on the third one, check and do it either way. So if I put the 3 in here, I have 9 plus 6 minus 15 over 9 minus 9. So again, we're 0 over 0, so we can use L'Hopital's rule. And when I'm looking at that, I take the derivative of the top, limit as x approaches 3, so that's 2x plus 2 over 2x minus 3. And I go ahead and just plug my 3 in now. So that's 6 plus 2, which is 8. And 2 times 3 is 6, minus 3 is 3, so my answer is 8/3. Or you can go back to the idea of factoring. So I need to factor that quadratic, so I'm looking for 2 numbers, multiply together give me negative 5, add together to give me positive 2, so that's, or sorry, multiply together to give me negative 15, so that's positive 5 and minus 3. And then I can factor out what they have in common here. So I have an x and an x minus 3. And now you can see the x minus 3's take each other out. And this is equivalent to looking at the limit as x approaches 3 of x plus 5 over x. And as you plug the 3 in, you see you end up with 8 over 3. Same answer as we got before. Okay, let's look at the next ones. All right, cosine squared minus sine squared over cosine minus sine. Okay, the squareds on top scream factor to me because I see that's the difference of squares. So I'm just going to go ahead and do that. So that factors to be cosine theta minus sine theta times cosine theta plus sine theta. And then on the bottom I have cosine theta minus sine theta. And you can see that that's going to cancel off. And now we just go ahead and plug the pi force into what's left over. Okay, so I have cosine of pi force plus sine of pi force. And this is root 2 over 2 plus root 2 over 2, which gives you 1/2 plus 1/2 is 1. So this is 1/2 of root 2 plus 1/2 of root 2. So it's just going to end up being root 2. All right. Now notice on number 5, you are going to infinity. X is approaching infinity rather than approaching a number like it has in the past. So what that implies us to do is remember our rules for our horizontal asymptotes back from pre-calc and from our limit section. So I look at the degree on top versus the degree on bottom. And if that has the same power, then I look at the leading coefficients. So since it's 2 and 2, I know that my limit is just going to be what's in front of my x squared, which is -2. And what would be in front of my x squared if I FOILed that out? And that, again, is going to be 1. You don't need to FOIL that out in order to see that, but I just did that for your purpose so you can see. All right, and so then this is just -2. Okay. Now look at number 6. Again, we're doing infinity. So you can see on top versus on bottom. So if you have the square root of x, that's the same thing as x to the 1/2 over x cubed. And so if you have x to the 1/2 over x cubed plus 5x squared, the top will grow a lot slower than the bottom. So essentially this bottom will blow up, become a really huge number because you're taking a really big number, infinity, you're cubing it, adding it to 5, infinity squared. Of course, you're not putting infinity in there, but we end up with huge number, small versus a smaller number. And so if you're taking a smaller number divided by a really, really big number, your limit's going to approach 0. All right, then we looked at the graphs for the limits. So on this one, we want to look at just how we're approaching. So if there's no little superscript on the 1, you need to go from both directions. So as I approach 1 from the left and from the right, what is my function approaching? And you can see that's 0. Okay, as I approach -1, okay, again, you have to go from the left and the right. So as I come from this direction here, you can see it is -2, but as I come from this direction up here, you can see it is 3. And since it is not approaching the same number from the left and the right, this one does not exist. Look at the limit as x approaches -1. This means from the right side or from numbers greater than -1. So that would be this side right here. And you can see as I approach from this side, 1, 2, 3, my answer is 3. I do not care that my value is actually 1 at that point. Remember, the limit is getting really, really close to -1, but it's not actually equal to -1. So you're riding this line up here to its answer. And as I go from the left side of -1, you can see I'm following this curve to its value, which is -2. Okay, now let's look at as I go to infinity. So as x goes to infinity, you're trying to say, okay, as x goes to infinity, you're going out this direction. So if I ride my curve, you can see that it's going down forever. So we write -infinity. And vice versa, if I go to -infinity, I'm riding this, I'm going this direction, so I hop on this curve, and it's approaching, because it's leveling out here, 1. So this limit is 1. All right, I hope that reminds you of our limits, and if you have any questions, feel free to ask. Have a nice night.